You will be surprised to hear that despite of all of these advancements in generative AI, especially all these huge large language models, and I'm including GPT-4o, which is one of the best LLM at the moment, there is still a huge problem with all of these LLMs, and that problem is of hallucinations. Hallucination refers to the process where a model generates or predicts output that is not based on any actual input or data, but rather on the model's own internal working or biases. This can occur in various AI applications such as text based image generation, language translation, chatbots, or any other. For example, an image generation model might produce an image of a cat when given no input, or language model might generate a sentence that is not related to the input prompt. Hallucinations can be caused by various factors, including overfitting, adversarial attacks, or simply the model's attempt to fill in the missing information. It is quite challenging problem in AI development as it can lead to inaccurate or misleading results. And researchers are actively working on developing techniques to detect and mitigate hallucinations in AI models. And I can tell you that still, at least I don't see in my limited knowledge any good tool which will at least ensure you that it is going to catch hallucinations, let alone mitigate it. That is why when I stumbled upon this paper around hallucination detector, I was quite intrigued. So these researchers, Sebastian, Janek, and Lawrence and Jaren, they have come up with this framework or tool or method that indicates whether an LLM is likely to have hallucinated its output or not. They what have done is that they have run some experiments on some of the models out there like llama 2 and few others on few of the very well known data sets, and then they have tried to guess if LLM's response is a hallucination or a real one. One of the interesting findings they have done is that even if the model mostly generates output with a uniform meaning, the entropy of the output can still be high since the same meaning can be phrased in many different ways. And one of the reasons why it is so hard is because we still don't know the inner workings of all of these neural networks, and that is quite scary. From the security perspective, I know these days this is all hype. We are very excited. We are actually over the moon about AI. But as this euphoria of AI will uh, taper down, I'm more than sure that more and more people will rise to this very grim reality of hallucinations. Also, the thing is that this could be a real challenge or obstacle to deploy generative AI applications in banking or law where it could be life threatening. And I would say that the way AI is going, there is a very huge danger of it going very wrong just due to the hallucinations. So that is why this hallucination detector is quite an interesting project. So in this video, I'm going to try to get it installed, and I'm going to also do an experimentation with the help of their detector on one of the data sets. So let's go check it out. Before we set it up, let me give a huge shout out to Mass Compute for sponsoring the VM and GPU for this video. If you're looking to rent a GPU on good prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. Okay, so let me take you to my terminal where I'm running Ubuntu 22.04, and then I'm also having this GPU card of 48 GB of VRAM, and that is NVIDIA RTX A6000. I will keep the environment as similar to what they have done in their experiments so that we would be able to reproduce the results. Let me clear the screen. Now let's first git clone the repo which they have provided. We are just calling it semantic uncertainty, and then not only we are cloning it, we also have strapped into that directory. Now next up, let's install all the prerequisites in this directory, and then I'm just going to activate it. So it is installing a lot of stuff here, and as per their repo, they say that it is going to take around 15 minutes to 30 minutes depending upon system configuration and then lot of other stuff. So let's wait for it to get installed, and then we will proceed further. So it took fair bit of time, but everything is installed. Next up, you would need to set three environment variables, and these are the ones. First up, you would need to go to huggingface.co and grab your free token, and you can simply just go there, go to your profile in settings, and you should be able to grab that. Then the second one, xtg underscore cache home. This is simply any local directory where you have plenty of space, because we will be also downloading a model, Llama 2 7 billion, I guess. So make sure you have around 30 to 40 gig of, or maybe 50 gig would be good, because we'll be downloading the model plus dataset. And then you would need to go to platform.openai.com and grab your API key from there. That is a paid option, unfortunately. So you would need that. There is also a fourth key you would need, that will be from WANDB. WANDB is weights and biases. That is a tool which is used to for the monitoring and logging of your pipelines related to AI, and there is a lot of stuff there. So you would need to go to the website wandb.com and grab it from your API key from there. That is free. Okay, so let me set my keys and clear the screen. So I have set my keys and cleared the screen. Now, in order to run the test, so that you could also see how the Llama 2 model does the hallucination on trivia QA dataset, you just need to run these tests from their GitHub repo. Now, once you run it, it is going to take 1 hour or so on a good GPU. So if you don't have a good GPU, that's a lost case. I'm sorry, but this is for the short hallucinations, which just measures it shortly. And there is also another test on their GitHub repo, which is for the long hallucination that even takes 2 to 3 hours. So let me run it to see how it proceeds. So you see, it is asking me that whether I want to use WANDB or not. So I already have a WANDB, and it says, so I'm just going to say 2 here. I already have WANDB key. Now it is saying me that paste your API key. So let me pause it, paste my key, because I already have it working. I'm not sure whether it will hide it or show it. So let me paste it. So I pasted it. It hasn't done anything, which is good. It means that it's not showing my key. It is just using that key here. It is now building the script. It is downloading the data set. And then it is just, you see, in which city was John Lennon murdered? New York. What was the Groucho Marx first name? Julius. So it is just using some of the trivia, and then now it is downloading the Llama 2 model. So there are two shards of it, around 10 gigs. So let's wait for it to get downloaded. The model is almost downloaded. It is now loading it to my GPU, all the shards of it. And the shards have been loading, and now it is running some questions answer, running the tests. And it is just going through that data set and trying to see what model does here. And you see there is a question, how many James Bond film, and all that stuff. So it is just going through whole data set. It is quite a big data set. So let's wait for it to run and see what it does. It is still running, and let me try to actually explain what exactly is happening here. So the authors have been generating answers to 5 open-ended question and answer dataset using various sizes of various models, but in this one we are using Llama 2. So given a question, the model generated 10 answers, and the authors have clustered the answers based on their meaning. And then they have judged two answers to have the same meaning if GPT 3.5 judged that the first followed logically from the second, and vice versa. And then they computed the probabilities that the model would generate an answer in each cluster. Then they computed the entropy using those probabilities. That is, that they calculated the model's uncertainty in the meaning of its generated answer. All answers to a given question were considered to have been hallucinated if the computed entropy exceeded the threshold. And you can see there, few of the accuracies are 0, and then some of them are giving correct answer, some of them are giving the different answer. And then there are 400 of them. So let's finish this 400, and then we will call it a day. But you got the idea that how they are testing it. And this is how they are trying to detect it with a mix of different models, mix and match. And by the way, one thing I want to also give you heads up, this is an also using OpenAI's API, which is a paid option, and this could go out of hand fairly quickly. So I was just checking my account in the previous run. I think for the just a starter ones, it already set me back around 20 US dollars. So it is not easy and cheap experiment, by the way. Anyway, I will let it finish it until 400 before it bankrupts me, and then we will call it a day. So let's wait for it to finish. Shouldn't take too long now, until 400, because it makes various passes. So you see it has started another iteration, and now it is saying that it is going to take 35 minutes out of this 400, and again 10 answers, 10 questions. So, and as I said, it is going to take 1 hour or maybe 2 hours. So I'm not going to wait for 2 hour, 1 hour, but you got the idea as what is happening here and how it works. So I'm just going to cancel it here. That's it. Let me press again it. That is good. And on your screen right now, you see that I am logged into VanDB's account, which is a free account. And this is where, if you look at the, uh, you know, sorry, left, this is our paper, the desert paper which we were using. And here the project is semantic uncertainty. And this is where it has used our train accuracy. And then this is the one it has used, and then len p true. And then if I open the system one, this is what it has used the GPU power, and then a lot of other stuff. VanDeep is awesome, and because it hasn't populated the hidden panels as of yet, and then there are a lot of information which it populates when it really completes, and you can check your number of hallucinations and that sort of stuff if you are inclined to run it for full. And this is one more thing which you can check it out from here when we ran it and all that stuff. So you can also generate reports if you're inclined to, because it didn't complete, so I am not really generating the report at the moment. So all in all, really good hallucinator, but I think still we would need something more easier, and we don't want to run it for hours and hours and just run it with OpenAI's API or any paid API that is going to cost thousands of dollars, if not hundreds of dollars. So we don't want to do that. We want something maybe which runs in parallel with local models like Olama or something like that, and we could use it to generate our detections of hallucinations. That will be more, I believe, workable. So that's it, guys. I hope that you enjoyed it. Let me know what do you think about this paper and this detector. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.